Right. Hello, everyone. Good morning. Impressive, amazing to see so many people here at CoG. The last time I was attending, it was called SIG and was in Santorini, and it was fantastic. But I also think some of us maybe spent some time on the beaches as well. So it's great to see a full auditorium in the morning. My name's Christoffer, and I'm the CEO and co-founder of an AI R&D company called modl.ai. Along with Julian and Jorgis, who are in the audience somewhere, and Sebastian Risi, Benedicte Mikkelsen, and Lars Henriksen, who couldn't make it here today. So this year I started being the full-time CEO of modl.ai, which means I don't get to code as much as I used to, and maybe not as much as I'd like to, but we have some fantastic people on the team doing that instead. Well, I was just introduced, but before I started doing this full-time, I've previously been both a professor, assistant professor at Northeastern University, and before that I was a director, producer, / programmer / bit of everything at a small independent game studio in Copenhagen called Die Gute Fabrik. By the way, we have a game coming out this fall called Mutatione, so if you want to Steam wishlist it, please go ahead. But that means that I've also had the chance to spend a little time on both sides of the fence, not in large game studios, but as a researcher and then also as an indie game developer. And what happened was that when I started doing my PhD in game artificial intelligence, I first learned about this thing called the gap that existed between academia and industry. And this seemed, at least in particular, to be the case in game artificial intelligence research, which is what I studied, where at the time many of the academic people I was talking to felt like they had a lot to offer, that there was a lot of fantastic research going on, but maybe also people were sort of experiencing a hard time finding a way of working with developers in industry or translating a lot of what they were doing into something that people immediately picked up in the game development community. I can also speak a little bit to this from the developer side, again coming only out of a very small game company. But running a small indie game development studio, I can say from that perspective, when we were working there, I think the case was that for most of us, we didn't really actually know how to work with people in academia. We maybe didn't even really understand that the opportunity existed. And even if we'd been aware of that, I'll tell you with the budgets that we had and the timelines we were working on, it would probably have seemed a little risky for us when we were building something that was a pretty classical game to start integrating a lot of what to us would maybe seem like esoteric or experimental methods into a tight production schedule. So when we titled this talk, Julian is my co-conspirator, he's here somewhere. When we titled this talk, we thought we'd start to look at we start out by looking at our perception, how we think about this presumed gap, and what the causes of it might be. And certainly a lot has changed, both in academic research and in the games industry, at least since I started doing my PhD. And I know something like the IEEE program here in the UK, for instance, is a great example of that. So I think every year we're seeing sort of the two parts coming closer and the gap closing more and more. But still, at the end of the day, we sort of think that you can still observe that there are differences in the ways that people tend to work in academia and in the ways that people tend to work in the game industry, for good reasons. So if we look at how we typically work in academia, or at least how I worked during my PhD, maybe some of you were better or more diligent, but often you have sort of like long cycles and what you might characterize as negotiable deliveries. So once you're working on something, you don't really know where it's headed and you don't really know what the outcome's going to be, but you know that somehow something interesting, as long as you're on an interesting path and you seem to be building something that's useful, well, there's going to be somebody out there, a community that will probably care about it, as long as it's interesting and good when it arrives. The methods that we're working on typically need to be novel. That's definitely the case in game artificial intelligence research. Otherwise, people probably won't be that interested in hearing about it. But thankfully, that's also something that's been changing a bit in recent years with a greater focus on the produced artifacts as well, something that I'm a big fan of. Also, you'll see on the academic side that often if you can solve something in principle, if you can show that it works for select cases, well, that's sort of, again, enough to grab attention and to get people interested in what you're doing. And there's an emphasis on whatever you're developing being cutting edge and, of course, generalizable, or at least in principle generalizable. It should be able to cover as many cases as possible. So the idea being that the proof of value is in the method itself, right? Looking over to the industry side, you're often seeing short cycles and hard deadlines for what you're working on. You're often seeing quick changes. As soon as you identify that something isn't viable or needs to change, you make a very rapid sort of like pivot around it and try and do something else. Whatever method you're implementing into your game really must work. There's not really a lot of leeway to spend time meandering around exploring things, or at least often not as much as you'd like there to be. And rather than having things solved in principle being interesting, having things solved in practice is really what's interesting when you're building a game right. It needs to work. It only really exists once you can play it, once you can feel it in the game. And that also means that the methods that you want to be implementing need to be controllable and dependable. And sort of like building off that, it's absolutely fine when you're constructing a method that it only works for your game in particular. Generalizability isn't necessarily a concern if you're a game developer working on one particular project, and the same probably goes for the tools that you're developing for your game. Of course, it'd be nice to carry them on to the next franchise, but at the end of the day, it just needs to work for the product you're building. So again, on the other side, from the industry perspective, perhaps there's a greater emphasis on showing proof in the product. And I think, one place where I've seen that myself in the game that we have coming out this fall, which is Shone, was when we were developing this game. It's a narrative story game. We had a bunch of interesting ideas for integrating all sorts of methods for creating emergence and having the game has a gardening component where we wanted to implement evolutionary principles, and you could sort of like build a garden and grow and have genetic mutations and offspring and all sorts of interesting things like that were either sort of like directly implemented or inspired by machine learning and modern game AI research. But at the end of the day, a lot of it ended up on the cutting floor, simply because we needed to finish the game on time, and our experiments were taking too long, and we needed to focus on the core experience of the game. So if anyone wants to discuss that in detail, we can always talk about that over coffee or beer at some other point in time. But anyway, the reason I'm here today and representing modl.ai is that we think that there's a great opportunity right now for bridging that gap. And the reason that we started the company is that that's exactly what we want to be working on for the next years. Working with great people out of academic game AI research, and working with forward-thinking game developers who are interested in taking these methods and implementing them and testing them out in the games that they're making. And in order to accomplish this, we've managed to put our first team together. And I just wanted to present the names here because a lot of them are out of the community and a lot of them are present here today at Conference on Games. And we're just incredibly proud of the fact that we could get all these people to spend some time working in this sort of like in-between space that we're working on covering in modl.ai. So thank you for trusting in that being possible. Now what we'll be focusing on in modl.ai is building general products for understanding players at scale and simulating their behaviors in games across play spaces in as many games as possible. So overall, we're working on building platform products for game developers, but we also sort of take on consultancy relationships, especially as we're a young company. We're working directly with a number of game studios to build things that are directly useful for them right now. And one of the best ways of thinking about sort of like where we're positioning ourselves and where this sort of like mythical gap exists is using this model that I borrowed from Yves Jacquier of Ubisoft, who in his recent DICE talk, he sort of identified this space in the middle that he calls the gap of wasted ideas. And sort of the point of his model is that if you look at all the different ways of working that we talked about for academia earlier, and if you look about what academics typically care about and are incentivized for caring about, their focus tend to sort of like drift toward the theoretical research and development and not as much the sort of like applied side of things. And on the other side, we're seeing that, well, in industry, again, the proof is in the product here, right? So it's great that we can look at and investigate all sorts of interesting methods, But really, at the end of the day, we need something that works. And if we can go with something we already know and keep using it to create a great game, I don't really see a business reason for why we would do that. You want to de-risk your production and get the greatest possible sort of like creative output, right? But Yves Jacquet's point was that initiatives that are happening right now in the games industry, such as, for instance, Ubisoft's La Forge, is positioned exactly in the middle here. And these initiatives are targeting bridging this gap and sort of like closing this, this missing connection between academia and industry. And it's fantastic to see how large studios are starting to have internal, and in some cases even sort of like multiple internal AI research departments that are addressing this problem. Now we're seeing actors such as not only Ubisoft, but also if you look at, for instance, EA Games, or if you look at King, all of these like large actors in the game space, these like high-tier game developers are starting to put together their own research teams, which I think is fantastically interesting and promising for the community. But of course, the other side of that is that most of the time we can sort of like probably expect their efforts to be directed at the products and franchises and tools that they're developing and that they need internally in these large game studios. That sort of makes sense and is probably the point of establishing these research divisions, even though you're seeing to a larger and larger degree that they are giving back to the whole community and providing things for everyone to use. At the same time of this, we're also seeing developments on the other end. We're seeing engine holders, platform holders such as Unity, who are they're like releasing tools that researchers and developers of all sizes can use to get started with modern game AI, but perhaps often sort of still at a level where you have to invest a little research and development, and maybe to a level that's out of scope for at least the smallest game developers. So what we're looking at, and we've been thinking about that for quite a few months in modl.ai, is that there might be another gap in the game industry. And this is this sort of like triangle pyramid thing here that I put up here is how we tend to think about the games industry at the moment and their relationship to game AI. The idea is basically that at the top you have these like global studios that are highly advanced who are capable of doing their own research and development departments. Then in the middle you have medium-sized studios, and what's a medium-sized studio? It's kind of hard to define, but it'd typically be a studio with maybe a few hundred employees that have a lot of structure in their organization. They probably have a lot of curiosity on using AI and machine learning in what they're doing, and they might even be doing it to a certain extent, but they don't have an internal research and development department, and they don't have sort of like initiatives for bringing that about, either because it's out of scope time-wise, it's out of scope growth-wise, it's out of scope financially, or maybe they've decided that they don't want to do that. And then, of course, at the bottom of the pyramid, you have sort of like the small indie studios or the hobby developers or the smaller teams who are using what they can get off the shelf or build sort of like highly bespoke, very individual things that they need exactly for their game. So the place where we're trying to positioning us as modl.ai, and the place that we're hoping that we can help the industry address, where we want to be working for the next while, is in that middle segment here. Because we've been talking to a number of game developers, and we've been seeing that there are a lot of actors out there who are really interested in using a lot of the methods that are coming out of this research community, but maybe don't know exactly where to start, or would like someone to take care of the most arcane parts of getting everything working. Now, of course, there are already sort of like, as I mentioned before, Unity and some of the cloud providers as well are providing product stacks and solutions that sort of already are starting to address this. But when we've been talking to the medium-sized game developers, what we've been hearing over and over is that there's still interest for someone who can help you package this and pick it up and put it in a format that's easy for you to work with your game, and maybe also give you some consultancy along the way and sort of like just help you get going, basically, with something that you can use for your game development process. The way that we've chosen to think about this in modl.ai that I wanted to talk about, and I'll just briefly sort of like introduce our product thinking, and then I'll step into an actual case where we used this. But this is sort of like the framing of where we're coming from and why modl.ai exists, I suppose. The way we think about AI services in modl.ai is from a concept that we call AI personas. And that sounds sort of like fancy or maybe sort of like a little opaque. But really the idea is that what we're working on in the company is to be able to recognize different kinds of players, predict what different kinds of players would do, and to the largest possible extent, simulate actions in game engines that fit different kinds of players. So we're not really a company that's oriented towards beating benchmarks or being the best at playing particular games. Rather, what we want to be the best at are recognizing different kinds of player behavior and simulating different kinds of player actions, because that's sort of like where a lot of our DNA comes from game design as well. And we think that's more important almost from a game design perspective if you want to understand an artifact, having something that represents your player base rather than something that plays at superhuman capacity. Or at least that's where we see a strong use case for game AI. Currently, we're building that into 4 different particular products. We have something underway that we call player archetypes that helps you recognize different players' psychological characteristics, basically, tell you why they're interested in playing games. We're working on game playing agents for particular kinds of games. We also offer anomaly detection, which is basically bot detection to a large extent, but could also be something like toxic players. Which was something that we weren't really considering initially, but then after talking to game developers, we learned that that's actually something there's a big need for in the market. Unsurprisingly, I guess. We just hadn't thought about it as yet another type of player. And we also offer services in personalization and procedural content generation. And what we really want to enable game developers to do with that is that we want to enable game developers to massively expand their playtesting capabilities. Not necessarily their QA capabilities. I think that's pretty well covered in many ways in the industry already. But we want to help people explore the play space of their artifact as they're building it. We want to help them balance what they're building. We want to help game developers predict player motivations from behavioral data. We want them to generate content for their games as they need it. And we want to assist content designers in getting started by having computers come up with suggestions for them. And okay, in the interest of time, I think I'm going to skip this video here and go right to the case. So I just wanted to tell you about one case that we implemented where we did this in modl.ai. And this was a case where we were contacted by a game developer who needed game-playing agents for game testing and balancing a PvP game. Now, this particular developer was exactly an example of that part of the market I was talking about. There are around 150 developers. They're focused on mobile games located in the United States, and they have really strong practices for organizing their data and sort of like running their DevOps, and everything is sort of like up and running, but they don't have an internal AI research department, and they're not really interested in constructing one. So they were building a game that was sort of a variation of a 1v1 player team battle where you have sort of like, this is the layout of the map, and imagine it's sort of a mix between Clash Royale and basketball and maybe American football. So you have 2 teams, and on one end, each player has 3 to 4 characters, and on the other end, the other player has 3 to 4 characters, and the objective is to grab a ball in the middle and move it into the goal at the end. Unfortunately, I can't show you a gameplay video here. But if you're interested in talking more about this case later, come see me and maybe we can take a look. But in this case, so the idea is you have this team. The team is chosen from a deck of more than 20 characters. Of course, all your characters can level up individually. And as you progress through the game, you get more points and you sort of like build your deck and your team. And as you're moving the characters around the field, you're drawing directly on the screen with your finger in order to play the game. Now, the developers who were building this, they were seeing a number of problems. They were spending increasing time just on basically just scheduling and playing the game 1 versus 1. As you can easily imagine, there's sort of an enormous combinatorial explosion in terms of how many different configurations, you need all the characters and all the decks and so on and so forth. So even just setting matches up was becoming a big problem, and they were spending 5 minutes per match at least. And they were playing basically every Friday, the whole development team. Game designers, programmers, backend engineers, everybody spent their time playing this game. They had also sort of like a massive challenge in balancing the new units, because even though they were going through these processes, they really couldn't cover the whole space, and they had this problem of maintaining overview and game balance. So in order to sort of like address this, we had a meeting with them and took a look at their situation, and we sort of identified this game as being a great target for some of the latest research in multicolored research. And we reviewed a lot of the literature, and we sort of figured out a way of adapting current sort of ideas in learning different playstyles for multicolored research by adapting heuristics, and made our own implementation of that. Now, all of the methods that we put into solving this were basically straight out of the research literature. And the thing that was sort of like bespoke or custom was really the integrations that we need to do in order to support the game that the client was running. The whole integration took us around 8 weeks or something like that, from the first meeting to the end. But then we were continuously following the client, and sort of like following up on their game as they were doing changes to the game. So the benefit for a client in a case like this was that we gave them, they actually achieved more or less what they wanted to. They had a new approach that helped them play test the game every time they made a change, and suddenly they could play 1 versus 1 against the AI, or we could run this headless in order to produce statistics and gameplay characteristics, just like we saw in the talk preceding mine. And from our perspective, well, we gained frameworks for deploying multicolored research to new examples of PvP multiplayer games, and we're actually generalizing this now to a system where we can support multiple, any game that sort of like runs under this type. So 3 major challenges that we've been seeing, not just in this project, but in other projects that we've been going into, where we take research-based approaches and use them to help game developers out with what we're building, is that the first question that often comes up is, when we propose a solution or a strategy for helping a game developer for implementing these agents for the game, the first question is probably, will it work at all? And sometimes we don't even know if it's going to work for the game. We have pretty good sort of like assumptions, but we can't really guarantee it. The other challenge is often, how long will it take? Because especially taking these like more research-based approaches where things aren't necessarily that clear, well then, in most cases, we need to sort of like have estimates, and a large part of that is just building standard ways of integrating. And another sort of like trepidation that we often see is like, how much maintenance support does this require? How much retraining will the models have to go through in order for you to continuously support the game's development? So all of these questions are things that we always work with our clients to scope out. But so far, we've actually found that the key way to sort of like enabling all of these questions being continuously answered is just having a very close development relationship with people as you're implementing these methods for them. That's exactly what we're working on in modl.ai. So this is our product roadmap. We're coming out with different versions of this over the coming months, over the next 9 months or so. And we are looking for people who are, of course, people who are interested in working with this in their games, but also research collaborators in industry and academia. So thank you so much, and I think that's exactly the 20-minute mark.